will sort of cease to be, if you will. I'm busy working tonight, but I will try to chime in whenever I can. Oh, thank you. Just enjoy the audio in the background. No worries at all. Don't tell him to stop working. Poor man or woman has to work. Go ahead and work and just to play this in the background. No worries. Spear Stephen T. Stephen? Okay. Why'd you put your Spears thing first? Okay. So let us enjoy in the background. So once again, because the virtual photons between the plates can only have resonant wavelengths, as in when the crests will match crests and the troughs will match troughs, there will be slightly fewer of them than in the region outside the plates where virtual photons can have any wavelength. Thus, there will be slightly fewer virtual photons hitting the inside surfaces of the plates than the outside surfaces. One would therefore expect a force on the plates pushing them toward each other. So like it's almost like when you have negative atmospheric pressure, like you know how if you have a plastic bottle and if there's a little bit of a vacuum inside the bottle, you know how the atmosphere presses on it, pushes down on it. So same thing, one would therefore expect a force on the plates pushing them toward each other. This force has actually been detected and has the predicted value. Good. Thus, we have experimental evidence that virtual particles exist and have real effects. So this is all a reality. Virtual particles do exist. These types of quantum effects, if you will, are not only just a thing in your brain, it's actually tried and tested. So this is the great success of quantum mechanics, if you will, where sometimes quantum mechanics will have bizarre predictions and bizarre things that are the outcomes of quantum mechanics, but you know, fortunately or unfortunately, well, unfortunately for the haters of quantum mechanics, they are tried and tested. The success of quantum mechanics experimentally is exactly why quantum mechanics continues to thrive. Remember this. There are people who don't like quantum mechanics, but they still have to be quiet and accept it because it has been tested and there are experimental successes. I wanted to mention that while we talk about these virtual particles. Share your drawing, yes. The fact that there are fewer virtual photons between the plates means that their energy density will be less than elsewhere. What? Okay, the fact that there are fewer virtual photons between the plates means that their energy density will be less than elsewhere. But the total energy density in empty space far away from the plates must be zero, because otherwise the energy density would warp the space and it would not be almost flat. So if the energy density between the plates is less than the energy density far away, it must be negative. So if the energy density between the plates is less than the energy density far away, it must be negative. Because overall, the energy density, the total energy density in empty space far away from the plates must be zero. So if it's something else in between the plates and far away, it's zero, then in the between the plates, it must be negative. Isn't that so crazy? So again, far away, because this thing is an empty space and virtual particles are part of empty space, far away, it's going to be zero energy density total. But what that means is that inside of the energy, inside of the metal plates, it's going to be negative, which is pretty cool. We talked about how energy densities are generally not considered to be negative in classical theories, because it's kind of like an overdrawn account in banks and money analogy. But in quantum,